Welcome and thank you for joining me for section 4.6. So section 4.6 is about completing the square. However, before we do completing the square, I actually have another technique that I want to spend an entire lesson working with you on. So far, we've talked about solving quadratics by factoring and solving by graphing. And today I want to review an idea that we exposed you to back in Expo by solving by square rooting. Okay, now remember this method only works in certain circumstances. Okay, this method only works when it does not have a b term or the x term in it, or sometimes I refer to it as the b term, because remember we're talking about ax squared plus bx plus c. So essentially what we're saying is that term is missing. Okay, so this method only works when you have something structured like that, where you have the ax squared and the c, the constant. Okay, and let's talk about how we solve this. Well, first step, isolate the x squared term. Okay, get the x squared completely by itself, and then you can square root both sides, remembering there's a negative and a positive solution. So what that's saying is you always get a plus or minus when you end up square rooting in an equation. You're producing two solutions. Okay, and I'll touch on why that happens when we actually dive into some examples. So let's work through a couple of these. Now again, this should not be a difficult strategy by any means, and in fact it's a review, but something I think is worth taking a day on, just to make sure you guys are feeling comfortable and confident with it. So remember, step one, isolate the squared term. So in this case, when I say isolate the squared term, what that means is I need to get this x squared by itself. So what that means is I'm going to have to add that 81 over. I add the 81 to get the x squared by itself. Next step, now we square root both sides, okay? So, square root, well, the square root of x squared is just x. Square root of 81 is plus or minus 9. Now, why plus or minus, okay? Because some of you may have forgotten why that ends up happening. Well, I think it's pretty obvious to you that 9 squared is 81, right? That's no shock to anyone. However, if you remember, I can also take negative 9, and when I square it, because a negative times a negative is positive, that gives me that very same 81. So that's where this plus and minus comes from, is because when you square a negative, it becomes positive as well, meaning both of these values actually solve that equation. Right, and of course, we can put things in there that get a little bit more complicated. So in this next one, okay, again, I still want to isolate that first, so I'm going to add the 72 over. However, this time the x squared isn't by itself yet. I need to get rid of that 2 right there. So I'm going to divide both sides by 2. And now the x squared is completely by itself. So now I'm ready to square root. Square root of 36 is just the number 6, but remember we always get a plus or minus because 6 squared is 36, but at the very same time, negative 6 is also, or it's this square, negative 6 squared is also 36. All right, and another reason I'm taking a whole day to review this with you is because there are some other things I need you to know too. For example, simplifying radical expressions, okay? So let's first get started and then I'll show you what I mean by this. So again, first step, I need to get that x squared completely by itself. So I'm going to add the 150 over. Then I'm going to divide by 3. And then just like my directions said before, square root both sides. So x equals plus or minus the square root of 50. Now this time, there's not a nice number for that, correct? We're not going to get a whole number answer. And so this is where, and this will actually come back in chapter 6, but this is where now we can simplify this expression. And again, I know you saw this back in Expo, but I did want to take a moment to refresh your memory on this process. This list right here, that is the list of perfect squares. Now, what do I mean by a list of perfect squares? Well, this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, so on and so forth. Those make up the perfect squares, and they are very, very important for when you're simplifying square roots, okay? Because when I look at that, I see the number 25, okay? Number 25 breaks down 50, right? 25 breaks down 50 into 25 times 2. And the reason that's important is because we know the square root of 25, right? We know the square root of 25 is just the number 5. So I'm going to write it as that. And so this is how I need this answer written. If it doesn't simplify to be a whole number answer, you should be checking to see at least does the radical piece simplify, okay? And it would simplify by a number in this list right here. Okay, those are the numbers you're searching to see. Can you break that radical down? Let's do another example. So, trying to get the x squared by itself because I'm being told to solve by square rooting. So I add the 48 over. Need to divide by 2 to get rid of that. And now square root both sides since I have the x squared by itself. So I get x equals, you need to remember the plus or minus, and this is another one that does not give a nice answer, okay? And when it does not give a nice answer, now we're going to go searching through that list of numbers, okay? So I'm going to check, do any of those numbers divide 24? And I see the number 4. Okay, 4 times 6 gives me 24. So I'm going to break that down into 4 times 6. Square root of 4 I know is 2. And then the piece I left inside, the 6, does not break down at all. All right. And the last one. We want to get the x squared by itself. So first thing I'm going to do is I'm going to subtract the 80. Next, I'm going to divide by -2, which lucky us flips that back to be positive. And now I have the x squared completely by itself. So I'm going to square root both sides to get x squared, or oh, sorry, not x squared, just x. X equals plus or minus the square root of 40. All right, so once again, now this is not going to give me a nice value, so I should be searching to see, all right, is there any perfect square that can break that number down for me? And consequently, actually, it's the same one. 4 breaks it down. 4 breaks it down into 4 times 10. And again, the reason I'm choosing the 4 is because now I know that that is a nice value. The square root of 4 is just the number 2. And so that is how I would like you to write your answer. And again, this concept will come back throughout chapter 4, little and 5, but then the big piece here, this is building chapter 6 up for you, okay? So this is an idea that it's going to keep coming back. But here's just a little exposure to how to simplify those radicals first. All right, So let's take a look at a word problem. So the lengths of the sides of a rectangular window have the ratio 1.6 to 1. The area of the window is 2,822.4 inches squared. What are the dimensions of that window? So it's telling us we have this rectangular window, okay, with an area of 2,822.4, and it's giving us the ratio, okay? So one side is going to be 1x and 1.6x. The other one is going to be 1.6 times bigger than the other one, okay? Because remember, whenever we don't know something, we start with x. Well, this ratio is telling us that that second side has to be 1.6 times the first side that we just labeled. And now that we know that, now we're actually pretty set up. So area, well, area is length times width, so x times 1.6x equals area. And in this instance, they actually already gave us that area. So now all we have to do is kind of simplify this up and solve. Well, here, x times 1.6x, just going to become 1.6x squared. And now we need to figure out how to get x squared by itself. Well, we get x squared by itself by dividing off that 1.6. And now I square root both sides. And that is going to give me x equals plus or minus 42. Now in this instance, however, does a negative answer make sense? And I hope I can pretty easily convince you that no, it does not. A negative makes no sense here because we're talking about lengths, okay, the lengths of a window. So in this instance, when you're dealing with the real world situations, here I'm actually only interested in the positive solution. Negative doesn't make sense because we're talking about areas and lengths. So what that's telling me is this side is 42 inches, multiply that by 1.6, and this one is 67.2 inches. All right, now a little flash forward for you, okay? Just looking ahead is another idea is what if the entire side of an equation is or has a square to it? Well, you can actually still end up square rooting it off, okay? So here, because this entire side is being influenced by the square, let's square root that whole side to undo that. All right, then square root of 16. Remember, you're always getting plus or minus in your answer. Okay, so this is a slightly different situation, but it plays out the same way. You square root both sides, and now you still have your plus or minus. So essentially, this is giving you two separate equations, right? You have x plus 3 equals positive 4, and you have x plus 3 equaling negative 4. So this time, your two solutions are a little bit different. You get 1 and negative 7 as your solution. So again, this you're going to see a whole lot more in the next section, but that's why I just want to expose you to this idea now. So you kind of get a glimpse at what's happening here. And this one, again, that squared is influencing that entire side of my equation. So I'm going to square root right away to undo that now plus or minus square root of 45. And this time 45, again, does not have a nice square root. So we leave the square root in there. However, we search, okay, because that actually does have a nice number that can break it down, okay? It can break down into 9 and 5. And again, the reason we do that is because now the square root of 9, we know that's 3 square roots of 5. And of course, that still equals the x minus 6, okay? But again, when you can simplify a square root, I need you to do so. And now to get x by itself, now we just add that x over. So I add 6, then we have that plus or minus 3 square roots of 5. And that represents my two solutions. So again, this is just a little preview that I want you to have so you kind of start getting some ideas that you're going to see in our next note video, okay? So thank you so much for joining me. Please make sure you take a moment, write that summary, and then come back ready to do your practice work in class.